Hi student, this lectures we are going to look at the phase diagram of um, lead and tin, and we are going to look at what is this phase diagram about, and how to identify various phases, and how to estimate the composition of the phases present in the various conditions. Remember that this exercise will be very helpful for you to understand the phase diagram and estimate the composition of the various phases, and including the density of the phases present in the system. Um, this is the phase diagram of the lead and tin. As we know that, look at this diagram. There is a, x-axis which says that the composition weight percent of the tin, which is at the bottom. The left side is the lead and the right side is the tin, which is basically the left side when whatever they specified as a tin, it is a 100% of the tin, 100% of the lead. On the right hand side, it is the 100% of the tin. Okay. If you look at the y-axis on the left side, it is mentioned in Celsius, and especially the lead melting point is 327 Celsius. And the right hand side, if you look at the temperature specified in the Fahrenheit, and the melting point of the tin is 232 Celsius. If you look at the top x-axis, the complementary x-axis, the compositions, which is whatever is of the tin, or the composition of the tin, which is presented in atomic weight percentage, and the bottom x-axis in the weight percentage. So you understand what I explained already. This what is atomic percentage and weight percentage. What the phase diagrams is about, there is a composition of the two elements. This is a binary phase diagram. We are going to see a lot of phase diagram. So what we are doing is, at the melting point of the lead, if we add fraction of weight percentage of the tin slowly, you see these lines, various lines which is representing the red lines. Okay, so the number of phases it is going to generate depends on the temperature and the y-axis. It varies. For example, if you look at the left side, the tin dominated area, the lead dominated area, there is the alpha phase. If you cool down within the 18.3% of the tin, you can see that there is a alpha phase. This region is a alpha phase. Alpha phase is a solid phase. And if you look at that, above 327 or along this line, above the line, so whatever you see that it is the liquidus, and it totally in a liquid form at whatever may be the percentage of the tin. If you look at this in between phases, alpha plus liquid of this melt, and the beta is another which is dominated by the tin. Okay, it is a solid phase. Basically, it occurs below 232 Celsius. Most of the composition is on tin. Okay, there is a beta phase, is solidus phase, and there is beta plus L, that is liquidus phase. If you that exists till the beta phase existed 97.8% of the tin, and the alpha phase exists till 18.3% of the lead also. If you, anything below, if you cool it down below the 200 183 Celsius, that's a kind of horizontal line, then it will come down to the alpha plus beta. It is a solid phase. So when you look at the phase diagram, there are various phases present, depends on the composition of the tin, and so we are depends on the temperature also. You will come across various phases. Okay, let us do a simple exercise. Phase diagram, that is a computation of phase composition at any phase which is present in the lead tin diagram. This is the exercise: determination of phase present in the computation of the composition. For example, 40 weight percentage of tin and 60 weight percentage of the lead alloy at 150 Celsius. What phases is or what phases are present? What are the composition of the phases? Okay. First, when you read the question, you have to look at, go back to the phase diagram and look at the clearly that first identify the phases for the 48 weight percentage of the tin and 60 weight percentage of the lead. And the temperature has to be below at least at 150 Celsius. You mark the line. Locate this temperature composition point on the phase diagram. Point B in the figure, in as much as it is within the alpha plus beta region. So here it is this temperature region and the disk compositions. This is within that alpha plus beta region. So both alpha and beta phases coexist. This is the phase diagram. Again, look at it. We have marked here point B. That is where we are talking about 40 and 60. Okay. So look at that. This is the C1. Okay. C1 is that point, exactly the point B. You drop a line on from the point B, that is a 40 weight percentage the tin and 60 weight percentage the lead, and the temperature is 150. That is how you have to mark it. So now you draw a tie line. This is called a tie line, a horizontal line parallel to the x-axis, which is intersect this point, and this will extend this line to both sides. So this point will intersect at the C alpha, that is on the near the alpha phase, and it also C beta, that is where it is intersect on the beta phase. Okay. So now we know that we draw the tri-line, we drop this C alpha, identify C alpha and identify C beta. C1 we already know that. So now look at that. What is that boundary about? So C alpha is denoted. If you look at that, it is the 11 weight percentage of the tin and 89% of the lead. Similarly, for the beta, if you look at the C beta, that is the 98 weight percentage of the tin and 2 weight percentage of the lead. Okay, so that's how you have to mention it. So you look at this point, draw a tie line, and you drop this line C1, C alpha, and identify this composition. Identify the fraction of lead and tin. Okay. Now it's a very simple exercise. You have to use a lever rule or inverse lever rule to find out what is the relative amount of the phases present. Understand that the lead has, if it is full of lead, it has the density about 11.23 gram per centimeter cube. So similarly, tin has the density 7.24 gram per centimeter cube at respectively. But the phase you identify is the composition of the alpha and beta. So now let us go to the how to find out the mass and volume fraction of the phases present at C1 or at the point B. So if you apply the find out what is the mass fraction, it is the inverse level rule, as I said that. Now what you have to do it, go back to that. So you wanted to find out weight fraction of the alpha phase, mass fraction of the alpha phase. What you have to do is find out this length. Okay, this is C beta minus C1. That is the this particular phase. So that is the how much weight it has to be balanced when you look at this portion. So if you want to find out what is the fraction of alpha phase, then you have to take this length divided by the whole length, that is C beta divided by C alpha. Okay, So now if you do that, that is a 98% minus 40%, 98 the minus 11%. So if you substitute the fraction of the mass fraction of the alpha phase is a 0.67, and if you look at this no, mass fraction of the beta phase is no. So again, if you go back and look at this, you want to find out what is the mass fraction of the beta phase, then you have to take this length from C alpha, no, C1 minus C alpha, then C beta minus C alpha. That's how you have to do that. So if you look at that, that's a 0.33%. So when you look at that point, we estimated that what is the mass fraction of the mass fraction of the alpha phase and mass fraction beta phase. How do you estimate the volume of that? So it's a very simple formula. You look at that, the density of the phase of that point B rho alpha, density is rho alpha. It is a composition of the alpha plus beta phases. So 100 divided by, you take it as this very empirical formula. C tin, I mean C tin alpha, how much tin is present in the alpha phase mass fraction of that divided by rho Sn, that is the tin density, and the lead present in the alpha phase divided by the composition of alpha phase divided by the lead density. So if you look at that, then we know that rho alpha is nothing but 100 divided by 11% is the tin, 89% is the lead. So if you do that, finally you will get rho alpha density is 10.59 gram per centimeter cube. So similarly, you calculate the rho beta, that is the density of the beta phase. So you have the composition of the tin, that is the beta phase, and that is the composition of the, that is the mass basically. So you find out that in the lead also. So it is a 98 and of the tin and 2 of the lead, that is the weight fraction. You divided by the corresponding density, you will get what is the beta phase density of the beta phase is 7.29 gram per centimeter cube. So now it is easy to convert. Use this formula. What is that volume fraction of the alpha phase? The volume fraction of the mass fraction of the alpha phase divided by density of the alpha phase. Okay. Similarly, if you take it as density of the mass fraction of the alpha phase divided by plus, because there are two phases present, so you have to take this fraction also. Total volume of the volume of that alpha phase divided by total volume. So the total volume is given by the denominator, and the volume of the alpha phase is given by the mass fraction divided by the volume of the alpha phase corresponding. So if you do that, you will get a 0.58. If you substitute all this value, you will get a 0.58. That is the volume fraction. And if you go similarly, if you apply that, you will find out what is this volume fraction of the beta phase. Basically what you have to do, that total volume that is on the denominator, volume of that corresponding phase, beta phase, is given by this formula. So now if you identify that, you will get this number. So 0.58 is the volume of the alpha phase, and 0.42 is the beta phase. If you again look at it, no mass fraction, in 0.67, 0.3. Why this variation? Because the density is different than the lead and the tin. So it is a composition of the lead and tin. So you will get different phases. Oh, this is a very simple way I demonstrated that how to find out how do you find out the various phases present in that for the particular composition and temperature, and how do you find out the mass fraction and the volume fraction of that particular composition. Okay, I hope that you just practice it. This is a very important exercise. You have to practice this, and you will basically you will understand. Only when you practice it, you will understand this issue, this problem successfully. You can solve this problem by practicing properly.